Hello everyone, welcome back to another video from Winter Forest. Today let's continue our recall question. Today's question is called all paths from source to target. And so you will given a directed scenic graph of n nodes. Find all possible paths from 0 to node n-1 and return them in any order. Look at the first example, so you will receive an array. Have 1, 2, 3, 4 items. So you need to return the path to 4 minus 1 to 3. So you always start with the node 0, actually it's position 0. From position 0, you could go to 1 and 2. Then you go to 3. So now you actually reach to the end result. Just let's draw a diagram. If I made this small. So we actually receive the results in here. So we receive an array 1 and 2, 3 and 3 and empty. You always start with 0 position, 0, 1 and 2 and 3. And this is the input. How you going to work, and you actually always start with 0. And when you come to this one, so we're going to use DFS. So you actually start with the current position. It is 0. You from 0 position to search from this graph up to, so this length is 4 minus 1. So up to the node, 4 minus 1 is 3. So if you could reach to the 3, then it is your one path you need to add to the result. So if we're going to start the index 0, the position with 0, we have I could go to 1 and also could go to 2. And you haven't reached yet. So you do DFS, so you continue working. And they have going to the 3. You could from 1 to 3. Also, you could from 2 to 3. In here, you already have 2 results. So it actually is 0, 1, and 3. Or you could from 0, 2, and 3. So if you reach this reach the destination, reach in here, you just add to the result. So you already have 2 results, 0, 1, 2, 0, 2, 3. So now you continue, you only up to here. If you're going to looping finish, you go into this 3, still the same. So it's exactly the same result. And then you continue go to 3. This is empty. So you already finish. We basically just use DFS search. Just be aware your last element always is empty. And you start the search from the position. Then you see what kind of path you could go 1, you could go 2 already, could find the path. Then every time you move this position, you just keep looping, find the path. Since we have the thinking in mind, so we just write the code quite straightforward. DFS search is quite straightforward. So kind of a pattern problem, you just need to practice more. So this is what we needed. The output is what we expected. It's called a path. And in the end, are going to return our path. And inside here, we do edge case check. If this graph equal to null, or this graph length equal to 0. And just return the empty path. Because you don't have a loss, you don't need to find. Otherwise, we're going to have a help function. We're going to do DFS. So it's part of, we continue call myself. We're going to continue call this function, and this function going to publish the path. What are we going to do in the action is we will pass this graph to the path. So we start the start position. Like I said, when we start the position is 0, and the current path and the current path is empty. And our result. Now we're going to write our help method. So we have this graph, and we have the position. We will looping from 0, 1, 2 up to here. And then we're going to have our, when you come in the current position, also the current path you already have in, for example, in here, from the 0, I could build a path 0, 1 and 0, 2. Then you move to 2, you already can build a 0, 1, 3, and 2 can 2 to 3. You already get the result. You don't even reach the end. So we need also have the current path. Then we have a final one we needed. If this is found, this path is reached, is the length equal to 4, we just put in this result. And now we just need to find our best scenario. If we go to the graph position, the length equal to 0. You see, if we reach, for example, reach in here, in this example special, you already in here, you 1, 0, 1, 2, loop to here, you already find 0. But what happens in other case, if you loop into the end, means you already reached the last element, so you just the current path. So add this position. Like in here, if you leave looping in here 0, 1, 2, 3, so you just add the position 3, and then you pass dot. Then this is one pass. Then you pass. Just add this one pass. Afterwards, then you get your result. Then you put a simple return in here. Otherwise, and just when you coming in, every time you coming in, you push. If you first time coming in, the current path, you will add the position. If this position 0, so 0 add in. If this is just start in here, it is 0, then 0 will be added in. Then for each of them, you just do DFS search, then you keep continue looping. and then call yourself, and the graph, it is the graph, and the position is different, is the graph position. For example, if in the 0 position, then you need a 0 position I, and for this item in this graph 0 position have 2 items, you need to do 2 times loop. So you in here you will add 0 1 0 2. This was the loop 2. So in this graph in the 0 position you have 2, you add in, and this is not the new this one, and it is not the empty, so you can't pass via in. So add 2, if it's 0, so in here after the first 0 it will have 0 1 0 0 1 and 0 2, and then go inside this path, then you continue until you find this position the length is equal to 0. That means you already added 0 graph 0 position. Looping finish graph 0 position, then you go to graph this position. And you continue looping. Yeah, this is supposed just do the job. Let's run the code. Because I copy paste to here also. Capital letter. Hit accept, and just explain it again. The code basically is to the what I explained in here. You start with the index 0 position. Once you come in, you just looping. You pick up from 0 index position. You could add a path to 0 1 and 0 2, and then you continue working on until this finish. Then you move to the next one. And in here, instead of like a matrix, so this one actually looping this the graph you passed the in. So if looping 1 0 and from 0 for 0 position have a 0 and 1, so you go into finish 1 and you pass the in the graph and 1 will have since the graph 1 0 finish, then you have a graph 1. Graph 1 have a position, then you finish it. Graph 1 only have a 1 position, so it's going to be finished. It actually in here only looping up to 3 position, then finish it. And quite very efficiently. And thank you for watching. Bye bye. I just submit as if pass every scenario, and it indeed. Thank you for watching. Bye bye.